Yeah,
So,
sounds good.
welcome to the developers meeting on 16th of April 2023. And I head over to IDO for demoing, for talks, for discussion, whatever. I want to raise, IDO, please, I want to raise 2 points,
Yeah.
which is that we talk about the RF team that is formed yesterday and about the
Mm-hmm.
goals. You were there, and about the goals and what we are intending to do. And
Yeah.
yeah, and basically updates from David, Fabio, but go ahead.
Yeah. So let's actually start with the RF team. So welcome Daria and Nicola.
Yeah, welcome.
Maybe you guys want to give like a small intro and discuss what we discussed yesterday about RF and goals.
Okay, let's start. Just a brief overview. So we met with Bob and discussed all the issues connected with passive radars. And so we decided that we will try to use Kraken, and he will hold some experiments with it in these 2 weeks. And he will download all the results to some folder with open access so we can get all the signals and so on. Me and Nikolai, we need it because we would like to make our analysis in it. And we will have our channel about this RF things and about passive radar. And now we started. So
Yeah. So I have to add a bit more to that. Also, I spoke with Joe yesterday more from Australia, and he has the Kraken as well. So he might be able to pull data to you as well. So if you want like specific bandwidth, and he knows everything about RF direction and all of that. So he's I think is already set up. So if you can ask him for data, he can provide you.
okay, is he already in the ref channel, and can I write him there?
Yes. I'll introduce you right after this call, and you can speak with him. Yeah.
Okay, so thank you.
And
yeah, so that's another reference besides Bob, with really good antennas and everything. So.
Yeah. One thing to add, Daria, you will also get a new role on Discord, which is a developer role, which gives you access to all the R&D channels. So when you go to, for example, a private channel, it's called Hangout, you can directly talk to someone of the other developers or raise a common discussion. But if it's dedicated to passive radar, you can also go into the passive radar channel and talk to Joe directly.
Okay, thank you.
Yeah.
So I think that the main idea that we started, and in these 2 weeks we will get the first results. If we can use one signal or we'll use another signal, and which results are we expecting to get in the end of the project, and if we can use Kraken or not, and which antennas will we use, and which algorithms, and so on. So.
Yep.
Perfect. Awesome. Okay, let's continue. Yeah.
Wait a second, Idol. One question to you. Correct me if I'm wrong, but I also heard from Bob saying that he wants to use a neural network that runs on the whole spectrum.
Oh.
And he trains a model on his computer because he has a fat computer, let's say, and the model that is coming out from that computer shall then be used on other platforms and Kraken combinations, so that this raw model, let's say, is then locally by recurring learning tuned to the local environment. Did I understand that right?
I would say even more. Like the vision again is to build a neural network for learning on the cloud. Because we're going to have a lot of data and we will need a lot of GPU to calculate. But the model, we will optimize it to run on embedded systems. Yeah.
Yeah. But the crucial
so
point...
that's the great vision. So, but we are again like really in early stages
of
figure out the data and really focus on calibration in the beginning.
Yeah, true, absolutely. I just wanted to raise the idea, that the path is towards a raw model that Bob creates on his computer that is then put on a local station so that it then can adjust itself to its local environment. Is this in some way correct?
I would say more abstract than that. Okay.
Okay, more abstract. Okay.
Yes.
Okay, got it.
Because again, we need to make sure that the model that we are building is reproducible.
Yeah.
Okay. So it can't only run on Bob's computer.
Absolutely. Yeah.
Right. We need to ensure the AI. So whatever we are building, we need to have the same. If given the same input, needs to have the same output, right? The same model.
Right.
So we will need to validate it. But yes, the reality is that it will run from Bob's computer.
Yeah.
Okay. But this is more about like the AI ethics, more, right? How we want to build it and how to validate it and everything.
Yeah.
Yeah, okay, I would like to add, as we don't know how it will go in the future, so for the beginning, I would like to know what clutter we have and how to improve our model and also how to introduce it to the custom device. Because I think that a person who will receive our device, he's not really into the serif things and so on, and he doesn't know where is the transmitter and if he has so much clutter, and we should give him some model that really works. And for this, nowadays we think that we should have some material to this, and maybe we will need some procedure to analyze firstly, just to set these parameters for the device.
Mm-hmm.
Yes.
Yeah.
Any more questions, anyone? Okay, so welcome again, RF team. Thank you for the help on that. Who wants to be next?
David, maybe David, can you hear us?
Yep.
Yeah.
Here.
Cool. Hey, David, you've shown me some stuff this last couple of days. Would you be able to demo that?
Sure. Yeah. It's not too much, but I'll just share my screen. Okay. Yeah, I was playing around with, as you know, last week with optical flow and looking at mapping the motion vectors to the HSV color space. I also kind of in midweek I looked at stuff that Yannick was doing with pulling weather data from that data source. I think it's Visual Crossing. So I was just looking to see whether the wind direction I pulled from the historical data aligned with what the vectors were showing me on optical flow.
Can you make the font a bit bigger? Sorry.
Yeah, sure. If I just... Any better?
Maybe. I don't know. For me, it's a bit small.
A bit more? Yeah, that's good.
Okay.
Yeah.
Yeah, so basically there's this weather API, and Yannick will be able to explain a little bit better than me, but you can pull historic weather data. If you've got a location and a time, you can get the weather from that period. So I was just seeing if it would align with what the kind of cloud direction I was getting from optical flow and the wind direction from the historical data, and it seemed to do reasonable have a reasonable alignment.
Yeah.
It's out by a few degrees, but I'm not really sure whether that's the way I've kind of aligned this in the code. And south is to the top of the fisheye view, but it's off by about 5 degrees. So I think that's kind of, I need to take that into account a little bit better. But I kind of cross-checked it across against a few different videos, and it seems to do, yeah, it seems to look pretty good. Now Yannick does, he's the weather guy, so he corrected me that, you know, wind direction that's measured and that's in this historical data is not necessarily going to be the same as at cloud level. So
okay. Do me a favor, after this call or even right now, disable your API key because you just expose it.
All right, sorry, yeah. So there's another video. So you can see the green one is the kind of average of these motion optical flow motion vectors.
Nice.
And the red vector is the red direction is just what's pulled from the historic data source. So
pretty cool.
Very cool.
Yeah, it kind of gives us some confidence in this technique for predicting. You know,
So do you think we can integrate it to the ROS2, like next?
yeah, I think so. I don't think it would be
Cool.
too complicated. I think I'll catch up with Mike about that
Yeah.
at some point, and we can try that. The other thing I picked up on, which might be interesting to kind of follow up and do a little bit more investigation on, is when you project these motion vectors into this HSV color space, you get the static stuff showing up as in a different color. So anything that's moving will have one color. Anything that's moving in the opposite direction or any other direction will have a different color. Or if it's static relative to the background, it'll have a different color. So maybe that's one way we could pick up on things that are staying aloft, as you would, you know, if it comes into the view of the fisheye and then just stays static, whatever that may be, then maybe you can pick up upon features from this optical flow. But it's just an idea that we discussed it a little bit last week. Yeah, that's all I've been working on really, and just collaborating with Fabio on potentially doing some stuff to
And do you know the bandwidth that it requires?
I'm sorry?
The bandwidth that it requires for the internet connection, like the data that you pull, like how much is it?
It's very little. I mean, it's just
No, I know it's little. Just still.
Yeah.
I'm thinking like, you know, for remote stations that have like limited connectivity, if they can still get the data or not.
Okay. Yeah.
Okay, think about like 3G, 4G. I don't know.
Yeah.
4G is okay, but 3G.
I mean, the reason I was pulling that data is just to try and.
No. I like it. I like it a lot.
Yeah.
Don't get me wrong. I'm just thinking like how much data it is, the bandwidth, because I'm trying to figure out with everything else that we are getting, because we will get also ADS-B and everything where we're going to be. So, you know, from hardware perspective, what will we need for internet connection? Not for those that have direct connection, for the remote ones.
Got it. Yeah. Okay.
But I think
So
you pull it every 10 minutes or so, right?
Yeah, I mean, the historical data we don't actually need. I mean, it's just I was just trying to cross-check against.
Yeah.
To see
cool.
if it would, just to kind of validate this approach for optical flow. I mean, optical flow doesn't even need to be calculated very often to determine this cloud direction, and you could maybe do it every few minutes, you know, and you don't even need to do it all the time. I mean, we've got a cloud estimator. If there's no clouds around, we don't even need to run optical flow to determine.
Yeah.
I mean.
Okay, so that's even better than I thought. Yeah, so that's good. That will work on remote. Cool.
Hey David, I have a question. The difference between this historic red vector and the current green resulting vector is about 5 degrees, you said. And I think you set the south at the very top in the center, right?
Yeah.
Or did you compensate with the true north?
I thought I did, but it's not quite working out. It's not quite aligning. But I think that's also due to the way this kind of mean vector, this average vector, is calculated, and it's calculating a mean based on all of the vectors across the frame. And you can see in some parts of the frame there's no cloud, so it's kind of biased. This mean vector is kind of biased naturally towards this direction anyway.
Yes, of course.
You've got like a distortion happening as well. So there's maybe some more work that needs to go on here.
What I know is from this material, the south is 5.6 degrees off. So if you would compensate your imported data by this 5.6 degrees, I think you get a perfect match.
Yeah, I should try that, shouldn't I? Yeah. I'll try that, Richard. Yeah, thanks.
Yeah, I don't have to do it now. Okay.
Maybe.
In one question, when you retrieve the data, does kind of a layer height come along with the data?
The height data. Sorry, the layer height.
When you retrieve the data from weather.visual crossing, or what was the server? Does it only deliver the wind speed for a certain geo coordinate, or also the height of the wind layer or the cloud layers or whatever?
Yeah, good question.
So as far as I know, it doesn't have the cloud layer height.
Okay.
So I started looking into this, but I didn't really have time last week. So there might be the NOAA. There's a NOAA API. So it's basically the North American weather service. But that I have to look into that more carefully, because the documentation of that API is quite bad. So I've used it before, but yeah, not for cloud layer heights. So,
are you familiar with weather reports from airport stations?
Not yet, but I started looking into that, and you're right. There was a hint, right, that we can use weather reports from from airports, right?
Yeah, exactly.
Yeah.
We did this once. It is 20 years ago, where we converted this in an SMS service.
Okay.
But actually, this is you get it from servers directly online. You can retrieve for any kind of airport. You get all the weather conditions. And the good thing is you get the speed of wind for certain levels. What we then need is a kind of interpolation between airports.
That's right. Yeah, because it's not super dense.
No.
Yeah.
Okay, at least an idea.
Yeah.
Yeah, because if we knew the cloud layer height, that would give an indication how close an object is.
You can also do.
Last week we already talked about that triangulation would also eventually work, right?
Yeah. Or an approximation towards, yeah.
Yeah.
You might. This wouldn't be highly accurate, but you could get. You could do some classification of the cloud type, and then get an approximation of the height based on cloud type as well. So just based on what kind of cloud it is, you'd have some idea of kind of height range. It wouldn't be that accurate, but it would give some information.
Yeah.
Every KPI is a good one.
Which API did you say?
No, I said every KPI is a good one.
Oh, yes.
So that's another KPI for a neural network. So it's good.
Yeah. Right. And we could do a some type of just classifier for a cloud type.
Mm-hmm.
Hey guys, we were talking about shortly now with David about the geometric north.
Yes, and we also had a slight conversation about it with this fisheye camera.
Yeah.
So maybe that's a good thing. Fabio, how are you?
Hey everyone.
Yeah. Why don't you speak about the fisheye? What we saw like yesterday, and Christian is here. Maybe he can help as well.
Yeah. Okay. So the question is which star shall we use in order to
let's speak about the fisheye and get into that, because there is a lot there.
What I saw, I posted on the AuSkyCam channel. If you can also take a look there, Christian, is that right now we don't get the full image from the lens inside the camera, inside the sensor of the camera. So we are cropping. I don't know, maybe 40 degrees from the beginning, or maybe more. I still have to check it. That's what I'm trying to work right now. Mm-hmm. And so right now we have a little. We have to figure out if that's okay, or we have to do something else. And if you look at the AuSkyCam channel, you'll see the problem. We have two images there that shows the. It's not a problem. It's just the way it is, but the problem is that we're not getting the full image from the lens. So we're not getting the full 20 degrees of the fisheye, and maybe not even the 180. So I still didn't do the check to see how much we're losing from the cut, but that's what I'm trying to do right now.
Yeah.
Because it's adjusting the focal length? The adapter, you're saying?
So, can you share the screen with the image?
Yeah, I can. Let me just put some shirt here.
Yeah, let's discuss it, because this is a good discussion. And that will lead also to who knows, Richard. It's important. I mean, I started this conversation.
Absolutely. But go ahead.
Yeah, I wanted to discuss also what ChatGPT answered you. Okay, but let's start with this.
Yeah, absolutely. But this is actually something that Christian was already discussing, I think, half a year ago. And it is.
No, but we need. Okay. Let's go back to it for a second, and let's continue with the image.
Okay.
Okay. The system has to agree on how to align everything. Okay. Mm-hmm. So and let's understand that that's an entire conversation that I want to include everyone, because there is UI settings for it as well, and it's a bigger object. It's not just for one sensor.
No,
okay.
No.
It's a system calibration. Okay.
Yeah.
So we'll discuss that separately. And that's why it's a larger issue.
Mm-hmm.
Okay. But to summarize, we already have one node service that does that has all the configuration in it that Mike created. Okay, but we need most likely to take it away and create a system calibration, a kind of node. Okay, and that's where all the configuration for all the nodes and everything will come from. So how to align it?
I would disconnect from here and connect from the Orange Pi. Okay.
Okay. So what? Okay, let's start with it because I already started. So Richard, you win.
What? Pardon me? What is?
No, from system calibration perspective, okay, all the calibration and all the configuration needs to come from ROS node. Okay, we already have that, right? It doesn't matter if it's your internal node. It doesn't matter if it's external node. But what I'm saying is, all the configuration like that, what is true nodes, what is that, has to come as a node parameter to the system.
Yep.
Okay, so what's important from coding perspective is that once you decide to move your code into the ROS2 environment, that you make that parameter a ROS2 parameter for configuration. Okay? And that means how to align everything. But you're right that alignment to true nodes is very, very important. It's important for the more than one system in this case. Okay, like the cloud from one perspective, the fisheye camera from another, and then the telescope also, right?
Absolutely, it's an intrinsic parameter we need to know.
Yeah, so that's kind of calibration needs to be a system-wide one.
Yeah.
Okay. So. Yes. Yeah, go ahead.
Oh, I can't hear him. Is he talking? Ido, is
yes.
Fabio talking? Oh, damn, I have to step out again.
Yeah, but he's on the...
So now at least I can hear a tweet.
So, Christian, if you can see this image, you see how much, from the fisheye we're getting cut. Christian?
Yeah, I see it.
Yeah. So it's kind of hard to hear, Fabio.
I'm here.
Oh.
Look at my...
Yeah.
So, I'm just here.
So,
yeah,
what I
the
see
question is this is acceptable, or we need to change something in the hardware.
Is there someone talking now?
No.
Okay.
No, I'm not talking.
Okay. So what I want to say is this is a 220-degree fisheye. And first of all, we do not need the 220. You see beyond the horizon. Yeah, this is beyond the horizon. So we would actually have to cut off from the 220 to 180. So that means 20 degrees on both sides. Let's say from the circle.
Yeah.
To reach the 180, but
yeah,
we won't reach the 180. I know, I see that, and
no, yeah,
we would certainly end up with 160, kind of.
Which is
yeah, that's
because let's say the 30 degrees above the horizon we won't be able to use because of the distortions of the fisheye lens, because of the projection. Below 30% below 30 degrees, we will have other issues with the atmosphere too. So we only can detect a position very, very much as an estimation, but not correct, because the disturbance of the atmosphere, the seeing will blur it. The projection type of the fisheye lens will distort it much more. So yeah, I think we're good with that field of view that we already have.
So the question I have is, will it worth working on zooming in a bit? Because we are losing those degrees anyway, so at least we get, larger size ISS.
You will not be able to zoom because we just have a fixed amount
I
of
have a few
pixels.
ideas.
So
I have a few ideas.
You mean cropping?
the square, so
Yeah.
we just have the same. Yeah, that's so. Okay, let me just.
No, but I'm
That's a random.
thinking about the hardware level zoom, so we get more of the picture.
Either you mean
Okay, yeah. So
cropping. You mean cropping?
no, not cropping.
No,
No. To
not
zoom,
to-
we have to figure out just a spacer. Between
Exactly.
yeah, we have to put a spacer between the camera and the lens, so we get a little bit layer.
Guys,
I do that. I do that with my telescope. So
Guys, may I interrupt in this? We were developing, we were modeling this adapter, and we tried the adapter to give a certain distance between the fisheye and the sensor, so that we get a sweet spot in sharpness into the infinity, which is 8 meters and away, in the center of the range of the focuser ring. Okay, so that we have, let's say, an elasticity to the left and the right, whoever attaches the camera to the lens. By that doing, we found out that the distance between the camera and the lens is a range of maximum 2 millimeters. And whenever you change this distance, you can then turn the focuser ring and resharpen the image. But you cannot put, let's say, a 1 centimeter distancer in between, because you then would never get a projection a sharp projection on the sensor.
Yeah.
This
Yeah.
here is the first adapter we designed with just the mathematics and the figures given from the data sheet, and this has a total length of 19 millimeters. With that, we have the right distance to get exactly the edges of the inner ring, of the inner circle on the chip, but we can't focus it. And so it is too wide. Now we are, I think the adapter has a height of, what was it?
I think 16.
9 millimeters?
No, less.
16.
More, 16
yes.
or 14, something like this.
Yeah, 16 like that. And we barely get into focus if we focus on unlimited. So we can't use the projection space, the back focus, to get a smaller image on the chip.
We would need another optic in between that compensates for that.
Yes.
Because those optics were not designed for the fisheye optics are not designed to make use with CMOS cameras in that type.
Yeah.
So the question basically is, do we have a problem or not? And actually, I do not see an issue. I mean, we can crop the image, or whatever you call it, this process that we take just the inner part of it, but we wouldn't get a better resolution. We just could crop the image.
it would just be like this. circle, but it will be like this.
Yeah, something like this, then centered, of course, yeah.
Yeah, we do not lose anything important because any object in the sky at that distance is distorted anyways. We can't do any position calculations. We can just say, okay, yes, there is an object, but we can't do any classification, any position measurement, any distant measurement. So we do not use, we do not lose anything. An object that is that low on the horizon won't be detected as an event anyway, because we can't do any analysis with that. And pointing the telescope to it, there's no point in that, because of the disturbance of the seeing of the atmosphere and other stuff that comes with that. So for me, it's good.
Okay, cool. So let's discuss. So Richard spoke with ChatGPT about.
No, wait a second. Sorry to interrupt you. Fabio, can you reverse what you just did so that you get the full view?
Okay.
Yes. Okay. So Christian, when you look at this view, you see that we cannot determine the exact center position, because when you turn the camera, when you loosen the three neural screws and you turn the camera, it depends how you tighten the three neural screws, and you would have to do it in such a way that you center the camera within the sensor field, and that's tricky to do.
Can you hear me, Richard?
Yes, of course I can hear you.
Oh, okay, perfect. Then, so that's something that I'm implementing right now. That's this circle here. That, for instance, you can start drawing the circle here, and then you have to do it also on the software, and also you do it here, so it adjusts to the camera, and then it can find the center, and then I can crop exactly on the place that we need. We don't need to do it manually on the screw.
I think there is a region of interest finder already in place. I think it's implemented in Python. It's used by the fire capture software. So we can reuse that code.
Yeah. Anyway, to do what? Sorry.
We can find the sweet spot for the centering part automatically by using some code from FireGL, from Fire Capture, because they have a region of interest finder algorithm.
Yeah, okay, we can also do that.
And you say
that's not something that's very difficult to do anyway, but yeah, we can use it.
Because it looks where no information is, the black part, and then cuts it to that.
Yeah,
and centers it.
Yeah, sure. Yeah, that's perfectly fine to do. Yeah, we don't need to my point is that we don't need to play with the screws or anything like this.
Yeah, okay. But actually, I see Fabio's solution is perfect. I mean, the user has to do it, but it looks simple. And we need
you should just
center point.
So let's discuss it from calibration perspective. Okay. There are two types of calibration that we want to do. Okay, manual and automatic. Okay. The goal is for everything to be calibrated automatically. Mm-hmm. And this what I will call is step one. Okay. Think about it also like from GPS coordination, right? So there is step one, you put physically over GPS. Number two, you get it from the GPS unit, right?
We need a kind of
True North is the same. We can start with manual and again, ROS2 parameter, and then we can convert it to doing that automatically.
Yeah.
Does that make sense?
Yeah, I mean, there's another topic to finding the true north, which needs a user interaction.
Yeah, but in the end of the day, what is important for the system is to have the parameter available.
Yeah.
And then we can adjust it automatically. We just need to find the right algorithm.
Yeah, sure.
Yeah.
But this is a very important part, to find the zenith in the camera. The camera's zenith.
So I think we need to have a discussion and maybe produce like a README file about system parameters. And then state which one we have and
it is there. We have a spreadsheet for this. We can add to that.
I think we need to map it to what we have in the ROS2 and update it.
Okay. Okay, so we shall start this process to have that mapped onto
and then
your ROS2
see
scheme.
like what we need for like alpha version.
Hey Fabio, sorry, your microphone is really hefty. I always have to mute you to hear others, which is weird for the record. You've got a better microphone?
Let me just a second.
So is Mike here? Oh, he's on and off, right? Good job.
Okay.
Yeah.
The thing is, the microphone is connected to the Orange Pi, to the. I don't have any better one connected to the Pi. So.
Okay.
No, I'm speaking. Mike, you here?
Yes, mate.
Yeah. Hey, you want to speak about more about the node that does all the configuration that you created?
Sorry, do you want me to elaborate on what it does?
No. So let's speak about it in the context of now that we need like more parameters, like the true nodes that we want to start aligning. Like a calibration of for example, the clouds and then the fisheye.
Okay. Yeah. So basically, it just contains a dictionary of parameters which it reads in from a config file, but you can update that dictionary as you use the application. I don't have the ability currently to repersist the dictionary to a config file, so we can't write the current set of settings out, but that's something we can implement. Yeah, and then it's just so it's the primary node that sort of starts up, and then all the other nodes, when they start up, they talk to it to get their list of configuration from it. And they also then listen to any configuration updates that affect them when they are made to the configuration node.
Yeah, so I think we want to continue with this pattern across all of our ROS2 nodes, right?
Okay. Sorry, just say that again?
So I think we want to continue with this pattern across all the ROS2 nodes.
Okay.
Right?
Okay. Yeah, so there is a base class. So there's a base node class that all the nodes inherit from, which is in the shared package, which gives this functionality. And then so that's easily done, and that is currently what is in place. So pretty much all the nodes do that currently.
Okay, cool. Yeah, so
sure,
guys, like if you want to start like moving stuff into the ROS2, we will have that configuration in place and everything for like the service pretty much done.
Yeah,
I'm
I
working.
was thinking that there are probably some updates that I could make by introducing maybe something like namespaces in the configuration settings, or right up a README to do with the configuration to highlight what it's used for. And I'm sure there are other changes and improvements that can be made to how it works, but it's, it works currently.
Yeah, where are we with the putting stuff like on GitHub issues and everything? Did we discuss it like 2 weeks ago? Sorry, I was sick.
No, I don't think
No,
we
okay.
covered any of the GitHub stuff. No.
Got it. Okay. So I think we discussed like 2 weeks ago that we want to move into GitHub issues, but we just need to discuss like the process of doing that.
Yes.
Right?
Sure.
Yeah. Okay. So let's find time to discuss it, maybe even through chat. So we are not getting too blocked on that, because that's becoming important. Because in my view of like managing all of it, when the teams are growing and everything, we need to get into the habits of like just creating issues and discuss everything through issues. So because we are so distributed, and we rely a lot on this meeting for a lot of decisions. So at least that can help us with kind of improvement of time, I guess. And this will become more of a fun meeting when we show like demos and stuff rather than discussing. Okay. Okay, cool. So yeah, okay, that will be fine.
So you want to go into direction that, for example, the example of the true north shall go into an issue topic.
Exactly.
Okay.
Yeah. So if we discuss true north, we need to discuss system calibration, and then the issues of the true north will go into the point to calibration that will point to the node a configurator that Mike created. So we have samples there. Yeah. So everyone can see all all of the discussion should be actually within issues.
So if we create issues, shall anyone create issues? How do we structure these issues? Do we attach them to certain teams or projects, or go ahead?
Yes, so I had a discussion with Fabio about it, and maybe it's a good time to discuss like in a broader conversation. So one way to change it is really by simple start moving into kind of pull request kind of development, when every pull request needs like an approval process. And that will be like don't think about it more like a normal code review, but more like addressing issues. So through like a pull request, we can focus on next step will be to put it in like a node, like a ROS2 node. Then it will be, the next pull request, how about, changing also to the configurator, like the parameters. And then you can create another issue about, right? So again, one way to start it is by moving it to a pull request mode. The question is if it's comfortable for everyone.
I also think another benefit of that, it improves collaboration as well.
Yes.
Because we get, we're not siloed. We get to see each other's code and what other people are working on and that sort of thing. So it's not necessarily a checkup process. It's more just, it helps with collaboration also.
Yeah, the whole point is for everyone to learn through that, everything that we have, the patterns that we're using, and find out where we are weak, and then create issues on making that stronger. For example, we can create an issue. We need to have better documentation of the X, system X, right? And then someone can take that off, and we can put it as like a documentation issue, whatever.
the normal way of project management that is done with, let's say, professional programmers or project personnel. Yeah, we at the beginning we thought of that and we tried to get developers into that, but it didn't work out because everyone had a very different way of doing developments. And yeah, I agree. We can start over with that, and
so I'm less speaking about
a much better structure in project management. Yes.
Yeah, so I'm less speaking about coding standards and stuff like that, but more like about system architecture and system design, right? That we follow the principles that on the system level.
The coding part was just an example for
that. Yeah.
Okay. We already tried that, and we skipped that and said, okay, let's do it later when
Got it.
The contribution was much more consistent with our vision of the project.
Yeah. So the first question is, if are you guys okay with this suggestion, or you have another suggestion that we can think of?
I'm sure you've heard of Jira. What about something like that? Maybe, I know a lot of people don't like Jira, but is there an alternative like that that's really good?
So Git issues is exactly like, I would say better Jira, in my opinion.
Oh, is it? Okay. Yeah, because everyone I know hates Jira. But it's great for organizing.
Yes, from documentation perspective and search and everything, you have all these capabilities within GitHub issues. And also what's nice in GitHub issues, you can reference directly to code, that's where Jira becomes weak. Also, the Jira started as a bug management system, so everything for them is a bug until today. That's a small Jira joke. Never mind.
Okay, so you're saying that, for example, with the Geodetic North, I shall create an issue, but how shall I assign the issue to a team or a project?
Yeah, so we can discuss, usually like an issue needs to sit under a repository, right? And you can move like an issue from repository to repository if needed, right? But now we need to discuss like who has the permission to do so, right?
To create issues, you mean?
No, create issues. I think everyone should be able to create issues.
Yeah.
Okay. And even issues templates. Like if you have another idea, go ahead and do that. So let's discuss that. Where do we want issues to be managed? Either a project, or under. I think it's under. Issue has to be under repository, and then I think you can pull it into a project. I need to double check that.
I mean, then we have to differentiate between project and repository.
I'm sorry?
So just so you guys... sorry.
Yeah. No, go ahead, Mark.
I was just going to say, just so you guys know, there is a backlog project that we created a while ago. So if there's any items that you guys want to add to that can eventually be moved into repository level issues, then you kind of more, you're more than welcome to add to the backlog project for now, just so that we don't lose it.
Yeah, but we have to differentiate between something that is going into the backlog, like a feature, an idea, but also some issues. Now, on the other hand, issues that are more troubleshooting or raising bugs or misbehavior.
Yeah. So again, there are two ways to manage it: under a repository, like normal issues, on under a project. Okay, but anyhow, an issue needs to belong to a repository. So I think we can start there, okay, and create the issue per repositories. But now we need to be smart about managing our repositories. So the question will be, do we want to retire, as Mike spoke about like 2 weeks ago, do we want to retire some old, like unused repositories, renaming the existing one? I suggest to start there before we start like, with the issues and everything.
Yeah.
Keep old one.
Does that make sense?
Absolutely.
Yeah, but don't delete the old one. Keep it.
No,
we'll archive it, but it's just going to become read-only.
Yeah.
When you're saying repos and when you're saying repos and projects, how are you? What do you mean by that? Because each repo, for example, handles a different aspect of what we're doing. So what would projects be? What do you mean by that?
So think about a repository as like a place for you to store code, right? Code, binaries, whatever, right? Files, basically. Or specifically a Git repository. A project is a GitHub feature that allows you to look at issues that belong to a repository or more than one repository from a project perspective. So it can allow you to have like a backlog and schedule issues and all of that. More like do like planning, project planning.
So you say if an issue belongs into more than one repo, then it goes into a project?
No. Issues can only belong to one repository. Okay? A project can oversee multiple repositories.
Do we?
Yeah.
Is it?
Okay.
Is it worth thinking?
I think we don't need to manage a project. Okay. We more need to start with issues because project is more about planning the future, and we are planning it. Our future is like what we are going to do next week.
Yeah.
Okay. We don't plan ahead like a quarter even. So I wouldn't recommend to start with project.
I was maybe thinking about issues being technical and projects being more business orientated. Or is that not?
Yeah, you can look at that because in the end of the day, when you start doing project management, you need to deliver a feature, a set of feature by a date, right?
Yeah.
That's a business, yeah.
So, do we have anyone that has maybe like that is interested in doing project management? Is there anyone that's, because I think it needs to be sort of
We might ask Jacques when he's there, because Jacques seems to do that for a living.
Yeah, that's exactly the person I was thinking as well, because I'm terrible at that, and yeah, I think we need someone that's sort of dedicated to doing that, and you know that is interested in doing that as well, sort of thing, you know.
Okay, and you said Jacques is doing this for a living, right, John?
Yeah, at least that's how I got it. Yeah.
Okay. Yeah. Okay. Just ask him. Why not?
Thank you.
Okay.
So what did we agree on? Are we turning on pull requests?
I think, like in my opinion, I think pull requests are sort of a good way to do not only code reviews, but also for people to get exposure to parts of the application that they wouldn't necessarily get exposure to. And so I think pull requests are are a very good way of doing, like, merging changes in. So I definitely think we have to do pull requests, in my opinion. I've sort of in the past, what I've already done is all changes I make, I get reviewed by, it used to be Paul, it's been Fabio, and whoever, just so that other people can also just see some of the changes that go in.
Mm-hmm. So who will want to do the reviews?
Someone that's quite strict, which is not really me.
I'll disagree with you on that.
Okay.
Because I think you can help a lot with aligning the code to the ROS2 way that you already implemented.
Reviews of what?
That's fair enough.
I'm sorry?
Reviews of what? Of what? The reviews of what? You know, you can review anything, anything we create. So I was wondering what kind of reviews you're talking about.
So that's right. You know, review is a multidimensional process, right? I think right now we are less likely to, you know, try to bulletproof, you know, an algorithm, right? Probably the person that is contributing that knows the best and did the best tests. But I think the reviews is more aligning to the system perspective, right? So do you think about how we are going to integrate this to ROS2? You know, make sure that you're using the configuration, right? You know, and very little kind of algorithm proof check. I don't think that's the intention of reviews. It's more about, again, people that understand the system, the architecture, and can help with the next steps.
Is it worth having, like,
because
having
I
a
don't
developer?
think we need to deny a pull request. I think we need to, not right now. I think we need to accept it and create issues out of it for the next steps.
Sure.
Right?
I was just wondering if it's worth having, like, a developer run through how the like the tracker works. And I know I'm probably the best person to try and explain how that works, just so that I can try and just answer some questions if there are, and you know, and just sort of try and facilitate a starting point, really, because I think at the moment probably there are a lot of guys that don't quite know where to start, maybe.
Yeah.
And
so,
you know,
so I think, look at it this way, right? Let's say that now David has no idea where to start with ROS2, okay?
Yeah, exactly.
And you know, I'll suggest, you know, first thing is issue by David, you know, on the his repositories, you know, pointing how do I integrate into ROS2, where do I need to do that, right? As simple as that. Another approach will be he can create a pull request into the tracker with an empty node folder for his own node, right? But that comes a bigger question, because now that points to how we're going to call that repository, because now it's containing more stuff, not just the tracker, right?
I wanted to say one nice thing about ROS2 is that it's very everybody can focus on one node and write code for one node, and then we just basically, almost like the concept of drag and drop, we can drag and drop that code into the ROS2 system. So all they have to do is learn about ROS2 and how to write a node. I think they would be fine.
Yeah, because another thing, just to second that as well, is that we don't have to have, the nodes don't have to be part of the tracker repository. They can be their own individual repository, and you just specify it in the tracker repository that you have a dependency on that node, and it will pull it in as part of the setup process. So if people are worried about kind of adding to the tracker repository, I don't think that needs to be a worry, because you can do it as an independent repository as well.
Yeah. So what I think, and I'll help a bit here. You know, we are going to have a lot of nodes. Okay, those are like microservices. We're going to have many of them. And I would say to start, you know, to have a repository for all of our nodes. And later on, we can probably break it down to like system level, or like what Mike, you call namespaces.
Sure.
Okay.
That's fine. Yeah.
But think about it like now we can create our, you know, Sky 360 standard node library.
Okay.
Okay. And I think that's a good repository for everyone to create issues with when they want to start integrating into the Sky 360 system.
Does anyone else have a view on that, or like, does anyone object to that, or is everyone?
So
I have a question.
Okay.
Hey guys. So we will download there some big issues connected to the overall project, like this one about this north issues, or some small ones like maybe in basic radars or in camera and so on. So what kind of issues will we download there as a repository?
Can you repeat that? Sorry, I didn't quite get your question.
Yeah. Okay. What kind of issues will we put there on Jira or something like this? Big ones or the smaller ones that are connected to the developer, like me, maybe in Passive Radar?
Yeah, I think we can try both, and then we can discuss like how to improve, like what works, what doesn't, right?
Or we can split. We can split big ones.
So big one create an issue because we can just need to label it as such, and most likely, you know, big issues we still want to, you know, have some sort of documentation of what we think about it. It's most likely like a large feature, right?
Can I ask a question?
Yeah.
At some point, won't all these nodes overload our processor or Pi? I mean, how much can you pile on that thing before it just crawls? I mean, I don't know. I'm just asking. Whenever I do programming, I have to be very careful about what I'm piling on, and it just sounds like we're piling on a ton.
Yeah. So eventually, think about it. Each of our when we are close, probably post alpha version, okay, and more like to the version 1 or whatever, we will want to know what's the performance that is required. Again, on a what I call a runtime policy, like of the robotic system per node that we have. Right? What's the memory requirement? What the CPU requirements? What's the GPU requirements for each one? Because that will allow us to map it to the best hardware.
I mean, shouldn't you plan ahead for that? What if you write all this and it won't run?
I can look. There are some requirements that we have to run. For example, the camera, you know, where the camera is connected physically, right? But there are some other nodes that requires internet connection. They probably need to connect to only the system that runs the internet connectivity. They don't need to run anywhere else, right? So we can map it that way. But there will be some nodes that most likely will not consume much that we can run on another hardware, and that's where optimization comes into play, right? So, for example, you know, I can find out that, and most likely that will be true, that I can run the GPS unit with the camera together on a hardware, because the GPS doesn't require much, right? Again, just an example, not saying that that's the case, right? Or we can figure out, for example, that on the Pi 5 that we have the neural network, and right now the camera doesn't use it at all, right? We might be able to run the neural network on it, right? Because the NPU is not being used at all right now.
So we're looking at multiple processors.
I'm sorry?
So we're looking at multiple processors. No idea how many we're going to end up needing in the end.
Yeah, we will see the overall node, and then we will see the requirement per system. You know what has to be, right? And then we'll figure out. But again, based on what it looks like, I think that we have a very good understanding to start. For example, the two Raspberry Pi, the two Orange Pi, right? And maybe potential NUC, right? I think we have a very good understanding of what we can deliver with, right?
Would it be a good idea to have a repo of just nodes, and that way everybody who writes a node puts it in a repo for nodes?
Yeah, that's what I suggested.
Oh, you did? Oh, I'm sorry, I missed it.
No, that's okay.
So that's a master repo then, isn't it? Because it contains all other nodes.
So that's pretty much what the tracker repo is.
Exactly.
The only thing to just maybe highlight there, or just add, is these sort of the unit, or I don't know, so generally a section of a ROS2 application is called a package. And a package itself can contain many nodes, and a ROS2 application can have many packages as well. So just all I want to say is just bear in mind that if you look at the tracker and you see a list of folders on the left, those things are packages, and each package can contain more than one node as well.
Yeah.
But I think that's getting too much into the details. Sorry.
So it's like an overall system.
I was thinking of something even more simpler, just for every person who's responsible for writing a node, they could just stick it in a repo, and then whoever needs to use that node, whether in the GUI or Simple Tracker, can then get that, the node from there and put it into their repo for the GUI or Simple Tracker or whatever. For example, we're going to have different nodes, and so coming from different locations and being used in different places. So it would just seem like it would be nice to have just a repo that is only nodes. For example, one for airplanes, one for airplanes, open sky, that kind of thing. And just have the node with nothing else. You don't have to sift through all the code or anything like that. That's what I was thinking of.
Yeah, I'd second that. I think that it would be good if each node had its own repo. That way we are very clear. That way a person can work on a single node without any big issues. And it's because we have an architecture that is sort of enforced by using ROS2. And the cut line is the node the communication on topics of the node. So I think having essentially repositories matching the architecture that every node has its own repo, I think makes a lot of sense.
I mean, so there's nothing. So if you guys need to author a node, there's nothing preventing you from doing that, right? You can. So I think I need to at some point just show you also how you can. So you can create a separate repository that is a ROS2 system, and in there you can basically point to the tracker and pull all the tracker nodes and the entire tracker repository into this new repository, and then pick which nodes you want to execute. It's kind of difficult to articulate, and I think I need to kind of demo it to you guys as well, so you can just see what I'm trying to say.
I think the problem. I think the problem is hierarchy. Mike, you have a repository for the tracker, the simple tracker repository, but this contains already several nodes, so you have to put it upside down, kind of. So to create multiple repositories.
Yeah, I know exactly what you mean, and I don't quite know how to separate. So, for example, the tracker. How do you separate? Do you separate it at a node level, or do you separate it at like a functional level? So, do you have a set of nodes which are to do with the tracker, and a set of nodes which are to do with monitoring, for example, and a set of nodes that are to do with classification, or do you break it even down further, where you have each individual package is its own repository? So so the level of detail is. Yeah. So I'm unsure as to what level of detail do you actually go to with it,
Yeah, that's why I think we need to start with one and then break down when we have better understanding. And this is the similar approach that ROS2 are taking anyway. And most of the time they will have a repo per multiple packages.
Yeah, I have certainly seen that, but I think I need to demonstrate what I'm trying to articulate as well to the guys, in that how you can create your own ROS2 project, and you can depend on another repository that has several nodes and pull that into your project without any coding at all. And then you can enable which nodes you want to run in your project from like your nodes or nodes that you've drawn in as dependency.
Yeah.
So I think because that might help.
Yeah. So how about we all take like a week to look into it, and then we decide next Sunday if it's like one repo for all nodes or multiple repos or per package or all of that. If we can't decide today.
I don't think so that we can, but we shall decide today. But I don't think that 1 week just waiting will help us. I think we should form a quick task group, let's say 3-4 people who are engaged, and just create a system for our GitHub that we all can work with.
Okay.
I think that is the quickest way to do.
Again, if everyone is fine with it, I'm good.
So my question would be, who would be interested in being in this group, reshaping our GitHub?
I'll be happy to contribute.
Yeah, I can probably help with that as well.
Okay, anyone else? Otherwise, you have to comply with whatever Mike and Ido is coming up. That's democratic.
Dan.
Either be in or be out. Okay.
So I think Dan's keen. Yeah.
Dan?
Yeah, Dan is volunteering, it looks like.
Okay, thank you. He raised his hand.
And then
you're muted. Dan, you're muted.
Okay, actually, instead of so let's make a faster decision, like Richard said. So I'll nominate Mike and Fabio to be the reviewers, if both of you are okay with it, obviously.
Yeah, that's fine, mate. Yeah.
And I can help also as a reviewer as well, I think.
I think it's a start, right? We've got to start we just got to start somewhere, I think, and then we can, it's not gonna be like this forever. So I think it's a start, and then we can, if other people want to review, they're more than welcome to as well.
Yeah.
So okay, this was a special question for reviewers. I wanted to go back to the GitHub team, the GitHub reshaping team.
Yes.
Dan, Mike, and Ido. You three gonna meet in the next couple of days. Can you arrange yourself a time when you're doing this?
Yes,
Sure.
I'm available. So you guys tell me when and fine.
Okay. Can you check this in DMs or so? Coordinate yourself? Okay, perfect.
Yeah, of course we can. Yeah.
Perfect.
And I think Fabio wants to participate also.
Yes.
He just had to go. So
Yeah. Okay. Hey, Ido, if any credential changes are necessary, give me a ping.
yeah. I think I'm good. I can do everything. I have enough permissions.
Yeah.
But if not, I'll let you know. Yeah.
Okay, perfect.
Yeah. But we will focus on cleanup, repository name changes to start, and then create the pull request kind of process with the issues and labels and stuff. Yeah. Okay.
Yeah. One question or one idea that Rebecca raised was whether it's a good idea to have a default node that anyone can pull and then reshape to her needs.
Yeah.
Okay.
So we can create that. I think it shouldn't take long to create one, honestly, because we have a base class and everything. So that we can create a sample node.
Mm-hmm.
That can be a baseline. Yeah.
Perfect.
The only thing I will say there is so the way we develop is we use like dev containers. So currently we have a Docker file in the Tracker repository which describes the dev container, and that itself has a bit of a container dependency. So if we were to make changes to the dev container, that would just need to be applied to all repositories that use it. Like, for example, if we bump the version, that version bump would need to go out to all repositories that use it, sort of thing.
Yeah.
So, yeah, but that we can talk that sort of stuff.
Yeah,
through,
let's fork it to another conversation. Yeah.
Yeah.
Cool.
Just a side note, I got feedback from Jacques.
Mm-hmm.
He currently doesn't have the bandwidth, the time, beside his main job to do it here.
Mm-hmm.
Project management.
Okay. But maybe either you can contact Jacques, maybe he has at least an hour time for going with you with this GitHub team onto GitHub, and maybe he has some ideas as well.
Yeah, I'll definitely speak with him. Yeah. But I think at least to start with issues is much more than we have today, so it's a good progress.
Yeah. Okay. One last thing is from my side is the True North discussion.
So I okay.
You're breaking up, Richard.
I'm breaking up. Hello, can you hear me?
Yeah, we can hear you.
Okay.
We can hear you. John, it might be on your side.
Interesting, because I hear everyone else. Okay.
Okay.
Let's discuss True North.
No, I'm just coming back to the question because we discussed it last weekend. You weren't there. Where we realized how important it is to know the True North, even for developers like Nicola who wanted to correlate with historic ADSB data. Sorry he's not here today, but
yes.
He was giving it some try, and I want to know what his update is on that. But anyway, anything we map is based on knowing the True North and where the center of the view is. So the center of the view is basically with Fabio's solution with a circle already solved. We can automate this in the future, yes. but the true north is still to be found.
Yes.
I was just playing with ChatGPT, and Christian, please, you didn't know what I was doing. I posted it in an All SkyCam channel. So my question to ChatGPT was, it shall create a simple code snippet in Python to calculate the difference between the y-axis of the view of a fisheye view that is pointing vertically, theoretically pointing vertically up to the zenith, and the azimuth to the star Sirius, because Sirius is one of the only ones that you can see on both hemispheres, so that anyone on the planet shall have a chance to click point to Sirius, and then we get the deviation towards north from the actual ephemeride of Sirius. So there's a library in Python that does all that. So the code is actually very short. Is that the way you would do it? The same?
You're talking about the library in AstroPy.
Actually, it's FRM, PyFRM.
Okay.
So you get the ephemerides of each star. Just add the name and the geolocation and time.
I have to look into that. In astronomy, we do it normally like this, that we look to the poles. The North Pole is very easy to determine because you've got the North Star, which is about 4 minutes away, and you can use drift alignment to do so, but that takes time for a fisheye and is not that accurate because of the low resolution of the fisheye. For normal telescopes, you can do that very, very easily with drift alignment. And if you do not have a pole, like on the southern hemisphere, you can use a star pattern to do that. This has the best chances to get.
So wait a second.
Right.
The star pattern.
Right.
If when you say a star pattern, you're talking about multiple stars. I was talking about just one star because we only need the
With one star, it's impossible to do.
Wait a second. We know the geolocation. We do not have to recalculate the geolocation because we know that from the GPS sensor.
So let's speak about the problem first. Okay, what we are trying to do is actually rotating the fisheye image to true north.
No, we do not rotate. No. We do not rotate. We only need the intrinsic parameter, which is the deviation from north.
Again, eventually you want to display that to the user. Okay?
Yes.
So you're going to display to the user the rotated image. That's the output of all of it. Okay.
Not necessarily. You don't have to rotate the image. I mean, you just have to point the north somewhere. Indicate, yes.
Again, it's the visual indicator.
And therefore, you just need the azimuth of the position.
Yeah.
Okay. You can.
Yes.
Basically, you can do it with one star any star that you know of the length of the travel time over the horizon.
Yeah.
From horizon to horizon.
Yeah, but then you need an object that moves fast. Otherwise, it will take you hours to calibrate.
No, it takes you 15 minutes, no matter where this star is. Basically, you can use any star. As long as you do it in the south or in the northern hemisphere or in the north of the southern hemisphere. I think it would be accurate enough.
Well, here we only need the azimuth, right? To true north. That's the only thing we need.
Yes.
So I think what I thought of doing is recognizing the 3 brightest stars.
Why 3?
And based on that, do the rotation.
Why 3?
You just need one.
You need
because
one.
you only need the circle.
But if it's one, then you're adding the time dimension, because I need to wait to see it moves.
Why?
But if I see that,
No.
if I'm looking for a shape that needs to appear in the sky, I think it will be faster.
Okay. So there is
That's
this
what I
library.
mean.
There's this library where you can correlate, where it finds the star in a view.
Yeah. So I think if I have a simple neural network that has as input the brightest point in the picture, and then align it to a shape, I think that will be a very easy calibration for azimuth.
There is astrometry.net doing such things, determined from an unknown image, an image of the sky.
Finding a star.
Yeah, it takes. They are taking not 3, but a star pattern of 4 and match it to a database.
Yeah.
And then we have to provide, let's say, the for the northern hemisphere around 3,200 of the brightest stars that can be visible. I think we can put it down to 1,600, but then we have to use a lookup table for that.
Yeah.
But the star Sirius is seen on both hemispheres, and it's a very bright star, -1.6.
So I think one issue with using select stars would be the person doing it would have to be able to identify that star to be able to do it. I think that the star
and Sirius is not seen during the whole year.
And if that's blocked in any if it's blocked in any way. But I guess there's another benefit to doing the star pattern too, is we can depending on what the fisheye camera, by looking at the star pattern and getting that and mapping that, we're able to get the exact, I guess the equation of the dome that we need to map to project that image exactly. So by using that star pattern, we get that adjustment. So we both get the true north as well as that equation by using that.
Yeah, this equation is pretty simple. It's just 2 vectors multiplied and divided by a third one. So you've got the position. But I think Sirius is not a good choice because here in the northern part of Germany, it's seen for, let's say, 5, not really, 3 months, because it belongs to the winter sky. For other seasons, we need different stars, or we have to concentrate on stars that are seen during in the sky during the whole year. They are called circumpolar stars.
Circumpolar stars.
Yeah, the more you go to the north, and the same is with the south too, then this region of the sky gets smaller and smaller. So okay, if we just put somewhere in the northern part of Norway, we have just, let's say, 20 degrees around the North Pole to identify some stars. At the equator, Earth equator, we do not have such a thing, because we will see, let's say, the whole north and the whole south, but nothing of the poles anymore. So the circle, the star rises in the east, reaches the zenith, let's say 12 hours after that, and goes and sets 6 hours later. So we have to find a system that is working on the whole planet.
What about using the sun?
Because it's an airy disk, we can't use it because we can't pinpoint the center of it, and the sun is too bright.
We could reduce the exposure rate to extreme minimum.
Not that much.
And then
that
okay, but then you get still a circle that you can find the center point.
Yeah, you've got a circle, and you can't use a circle.
Yeah, but you can find the center point of a circle.
Not really, because of the atmosphere. It's not accurate enough. You do not use any airy disk. You do not use a planet. You do not use the moon or the sun for such a task.
For finding north? Sorry, for finding north, every pathfinder uses the sun to find north.
Yeah, but to a point of at best a degree, and a degree is a lot in the sky.
Okay.
So what's the main issue with using a star pattern?
I don't see any issue with that.
No, it's just a different question. If we use several stars, we have to first see where's the geolocation, and then from that select from the almanac of stars which ones we're looking for. And then
based, yes.
Use an algorithm, an external one. That's the bad thing.
So, Richard, also just let's have this discussion in GitHub. It's like I want to document this decision, under an issue.
Okay, but yeah, we can do that.
Okay, so we have
this is also documented.
Yeah, so we have the calculation in place and the understanding.
Yeah, okay, makes sense.
We can try multiple approach, and again, we can have manual to start, and then continue with automatic. Right?
Yeah.
Sorry, I have two idea about True North. Will we use 3-axis compass sensor with magnetic north?
They are as inaccurate as using the sun. Magnetic compasses, they are accurate to 5 degrees, but not more.
Yes, it has magnetic declination.
They are basically accelerometers, and they can measure the turning rate very exactly, but they are not position sensors.
They tend to also have a magnetometer.
There is a position sensor. They exist. But anyway, the problem...
if it has a magnetic declination and we will and we have GPS location, we just use internet table location and magnetic declination in area.
That is inaccurate too, and there is a difference between the magnetic pole and the true north pole.
Yeah, so there's deviation that he said with deviation. So you can adjust to that. But the problem is somewhere else. The problem is that you imply that you know that you have to fix your device that giving you geometric north onto the fisheye. And you have to bring these two into a certain mounting so that now we have the issue that there's a fisheye which is rotational the same, and we have a camera which is rotational the same. So whenever you mount that, you have no idea how you turn it. But then we would need a kind of a sensor that hooked onto the camera so we then can correlate with the orientation of the camera.
Okay, look. You can't rely on a single sensor to do a calibration. Okay, not when you're speaking a system that has multiple sensors that does fusion. So you want to rely, the more KPIs that you have, the better. Okay, and each input that you have is going to help you eventually with the calibration, Kalman filter, or whatever it is we select, okay? But it gives you, like as Christian said, a certain amount of guarantees, right? So I think if we can get a KPI that gives us 5 angles guarantees, it's good to start. We can fuse it together, again, in the neural network with that's the sky align to what we receive from the internet. If not, we can probably improve the accuracy, but dial in, right? But that's, the end automatic calibration will happen through a neural network. Okay, so whatever gets us KPIs into the neural network, I think is important. It doesn't matter if it's coming from a software algorithm or hardware.
Basically correct. In this case, it's not correct because you get a sensor from with a magnetic north indicator, but it depends where you put it.
Look, I calibrated the border protection cameras, okay, with inaccurate GPS and 3 axes that, that device was old, and we managed to do that. You need more time, more sampling, but eventually the data was useful. Okay, over time with Kalman filter,
your camera has to be fitted with the sensor. That has to be geometric.
You're never going to get a 100% accuracy. Okay, you're going to get close to it. And again, the most important thing that we will need to calibrate is the telescope, and the telescope needs to have good enough direction to where the object is moving. But once the telescope captures that object moving in its frame, it doesn't care about anything else, and now it cares about its own data and its own calibration. Okay, you just need to have a good system to get it to the object. Okay.
The thing is that the cameras that you used, and they may have had a magnetometer or accelerometer, but those were probably series produced cameras where the alignment between the camera's rotation and where the sensor is, it's always the same. These are home built, right? So may not, be within a certain error range of this relation.
Yeah.
The calibration or the alignment of the PTF and the fisheye is pretty easily done because you know exactly the distance between them, and the alignment for the PTF can be done with a 3-star alignment. This is common and this is accurate. And you do not need any drift alignment. You can do it, but you don't need it because you have the height position and the azimuth. So you're good with that. I don't see any problem with just using for the star pattern method for the fisheye, and the same is done with the PTF too. And so you've got a fix.
Yeah. But improving the filtering of the clouds and the lining, we need to have more accuracy. But I think between the inaccuracy of, let's say, the azimuth of the image and the more real data, how the clouds look like, I think we can have a better matching there and give a feedback to the fisheye. This is the true azimuth, or this is a better azimuth for you to use.
Yeah, we do not have to be accurate down to 2 arc seconds. I think if we're in a range of, let's say, 1 to 5 arc minutes for the true north, we are good because of the resolution of the fisheye.
Yeah, you still need to explain to me arc minutes.
An arc minute is
write that down?
the 60th part of a degree, and an arc second is a 3,600th part of a degree. So it's pretty easy to calculate.
Mm-hmm.
Can we write it down somewhere? I mean, these kinds of requirements are important, I think.
Yeah, so that's why I want to start putting everything under issues in GitHub. So we
have that documentation already in place because it's in the description of how to calculate what camera is good with what optics.
Google Drive.
Yeah.
Documentation all there.
Yeah, but I think we'll start either pointing to it, through issues or moving some of it.
That's certainly a good idea to roll out by an issue. Yeah. I will start an issue describing the North topic, and you can put it then move it where you think it fits best.
Yeah.
I was wondering, so you're using celestial coordinates? You're using celestial coordinates to point out what's in the sky?
Geo-coordinates. We map everything to geo-coordinates. Yeah.
Okay.
Yeah. That's basically it. So we're settled with the importance of the true north, and I think we have some ideas how to achieve that. And yeah, let's put that in an issue and talk from there.
Sounds good.
Okay, guys, it's a couple of minutes to the clock. Actually, I wanted to use, he's gone. So there's a new developer, Kian, he was there. He left a couple of minutes ago. Next time, Kian, if you see this, next time you give a short intro about yourself. So with these words, I close the development meeting for today.